Imagine a construction site where robots lay bricks, pour concrete, and even 3D print entire buildings. Automated construction and robotics are revolutionizing how we build, making projects faster, safer, and more precise. From high-rises to disaster relief shelters, these machines handle tasks that once required massive human effort. With AI, sensors, and 3D printing technology, robots are changing architecture, engineering, and construction forever. Today, we'll explore how robotics is transforming construction, the technology behind it, and the incredible impact on efficiency and safety. If you love futuristic technology, make sure to like, subscribe, and hit the bell icon so you never miss updates on innovation. 1. What is automated construction? Automated construction uses robotics, AI, and machinery to perform building tasks with minimal human intervention. Robots can lay bricks, weld steel, pour concrete, and operate heavy machinery. AI systems optimize building sequences and reduce errors. Automation improves precision, ensuring every structure meets exact specifications. Some robots can even 3D print walls layer by layer. This technology reduces labor costs and speeds up construction timelines. Human workers supervise and maintain the machines rather than performing dangerous tasks. Automated construction is becoming essential for large-scale projects worldwide. Its potential extends to urban planning and disaster relief construction. 2. Robotics in bricklaying. Bricklaying robots can place thousands of bricks per day with perfect alignment. They use sensors to maintain spacing and adjust for structural accuracy. AI guides the robots to follow building plans efficiently. Some robots mix mortar and apply it automatically. This reduces human labor and error on large projects. Robots work continuously without fatigue, improving overall productivity. Advanced systems can even handle complex architectural designs. By integrating robotics, construction timelines are shortened significantly. Safety on site is enhanced as humans avoid heavy lifting or repetitive tasks. Robotic bricklaying is now a reality in modern construction. 3. 3D printing buildings. 3D printing in construction involves layer-by-layer deposition of concrete or other materials. Large-scale printers can create walls, floors, and entire structures autonomously. Designs can be intricate, customized, and optimized for material efficiency. AI ensures precise measurement and structural integrity. 3D printing reduces construction waste and energy consumption. Emergency shelters can be printed quickly in disaster-stricken areas. Some projects now feature multi-story buildings built almost entirely by robots. This technology also allows rapid prototyping of innovative designs. Human workers supervise but do not manually perform repetitive tasks. 3D printing is redefining the limits of architectural creativity. 4. Types of construction robots. Construction robots vary depending on their tasks. Bricklaying robots focus on masonry work. Crane and heavy lift robots manage large components and materials. 3D printing robots build walls, floors, and even bridges. Autonomous vehicles transport materials around the site efficiently. Inspection robots monitor structural integrity and quality control. Some robots specialize in demolition and cleanup tasks. Hybrid systems combine multiple capabilities for complex projects. Each type is designed to optimize efficiency and safety. New designs continuously emerge to meet specific construction needs. Robotics offers a versatile toolkit for modern builders. 5. Sensors and AI in construction. Robots rely on sensors, cameras, and AI to navigate construction sites safely. LiDAR and GPS systems map sites accurately. AI algorithms analyze terrain, detect obstacles, and plan efficient movements. Sensors measure temperature, material density, and structural alignment. Real-time data ensures robots maintain precision in every task. Safety protocols prevent accidents around humans and machinery. AI optimizes material usage and workflow sequences. Continuous monitoring improves quality control and project efficiency. This combination of AI and sensors ensures reliable, safe, and fast construction. Technology reduces mistakes and increases productivity on site. 6. Safety and efficiency benefits. Robotics makes construction safer by removing humans from hazardous tasks. Workers avoid heavy lifting, repetitive stress, and dangerous heights. Robots maintain consistent performance without fatigue or error. Construction timelines are reduced as machines operate continuously. Material usage is optimized, reducing waste and costs. Quality control improves due to precision and real-time monitoring. Complex or dangerous projects become feasible with robotic assistance. Human oversight ensures safety while maximizing productivity. Automation in construction benefits both workers and project managers. Efficiency gains are transforming the industry globally. 7. Cost reduction and sustainability. Automated construction reduces labor costs significantly. 3D printing uses materials efficiently, minimizing waste. Energy consumption is lower compared to traditional methods. Fewer errors mean less rework and reduced project delays. Robots allow for rapid construction in disaster relief or urban expansion. Sustainable materials can be integrated with AI planning for eco-friendly buildings. Long-term maintenance is easier due to precise construction standards. Cost-effective projects encourage adoption worldwide. Robotics supports green construction practices without compromising speed. Sustainability is a major advantage of automated building. 8. Challenges in robotic construction. Despite benefits, challenges remain in robotic construction. High initial investment is required for machines and software. Complex terrains or unstructured sites can confuse robots. Maintenance and repair require specialized knowledge. Integration with human teams needs careful planning. AI may struggle with unpredictable obstacles or design changes. Legal and regulatory frameworks are still developing for autonomous construction. Ensuring safety for humans nearby is critical. Despite these hurdles, research is rapidly improving technology. Overcoming challenges will expand the adoption of robotic construction worldwide. 9. Innovations and future trends. The future of construction robotics is exciting and innovative. AI will enable fully autonomous sites with minimal human supervision. Advanced 3D printing will create multi-story buildings efficiently. Robots may self-repair or adapt to changing site conditions. Swarm robotics could coordinate multiple machines for complex projects. Sustainable, eco-friendly construction will be optimized with AI and automation. Drones may complement ground robots for surveying and material delivery. Future designs will integrate sensors, AI, and modularity for maximum efficiency. Automation will redefine urban planning and infrastructure development. Construction will become faster, safer, and more innovative than ever before. 10. Impact on the construction industry. Robotics is reshaping the construction industry entirely. Projects are completed faster, safer, and with higher quality. Labor-intensive tasks are reduced, allowing humans to focus on planning and supervision. 3D printing and automation unlock architectural possibilities previously impossible. Costs and environmental impact are lowered, creating sustainable solutions. Collaboration between humans and robots increases efficiency and safety. Companies adopting robotics gain a competitive edge in the global market. Skills development now includes robotics operation and AI supervision. The future of construction will be dominated by intelligent, automated systems. Robotics is building a new era brick by brick. From laying bricks to printing entire structures, robotics is transforming construction. Faster timelines, safer work environments, and precise results make automation indispensable. If you enjoyed this video, hit like, subscribe, and turn on notifications for more insights into futuristic technology. Share with friends fascinated by innovation, and comment which robotic construction feature impressed you most. Stay informed, explore innovation, and watch the future of building unfold.